All right, today we're going to do 7.5, which is special types of linear systems. Obviously, disregard the date. What we're going to talk about in 7.5 is when graphing lines, I know how many solutions they have by what type of lines they are, okay? In 7.1, if you remember, we would graph lines, all right? We'd put them in y equals mx plus b form, graph each line, and where those lines intersected, that is my solution. That's how I would know. So I know the lines that intersect, they're going to have one solution, wherever they cross one another. Now, I know lines that intersect, they'll never eventually intersect again somewhere, because they're still going. They'll never curve and go back around because a line is straight. So I know that to find a solution, all I've got to do is find where the lines intersect, all right? Now, you don't need to write this down. I'm just going to talk about it. We just talked about the first one. When using the graphing method to solve the linear equation, how do I know my solution? Well, we just said whenever you graph it, it's where the lines intersect. So I know in order to find a solution, I've got to figure out where the lines intersect or how many times they intersect. With the lines that we were doing in 7.1, there was just one solution because they only intersected at one spot. But what happens, okay, in this next one, what if the lines never cross? I never gave you any of those in 7.1. Your lines would be parallel. They're never going to cross. They're always going to stay the same distance apart, and they'll always go side by side, but they will never intersect with each other. So, process of elimination, if I know that where the lines intersect is my solution, if my lines never intersect, will I have a solution? No. So if I have parallel lines, I have no solution. Okay? What if the lines turn out to be the exact same? What if I go to graph them and they're identical? How many solutions will they have? Well, every single point they go over is a solution. Because remember, if it's where they intersect or where they cross one another, these lines never leave one another. They stay the exact same. So every single point they come in contact with is a solution. So if I have the same lines, I have an infinite amount of solutions. Okay? So I have three different types of lines that we're going to learn about. Intersecting, parallel, and same lines. All right? Go ahead and write this down. I want you to get everything down on this. Okay, so on the last thing we talked about, there were three different types of lines. I have parallel lines, lines that are going to turn out to be the same, and then lines that will intersect. So these are my three types of lines. Now, typically, in order to figure out what kind of lines they are and how many solutions they will have, I would need to graph them. But I'm going to teach you a way to find out what type of lines they will be without graphing at all. Okay? Save you some time, save you graph paper. The first thing you have to know is right here. Put a box around it, star it, underline, do whatever you need to do to know, if I do not do this first, I will not get the right answer. In order to find out what type of equation it is, I have to put it in slope-intercept form first. Before I do anything, it has to be in slope-intercept form. Okay, what is slope-intercept form? Y equals mx plus b. Okay, I know that m is my slope, b is my y-intercept, and those will be numbers, you won't ever actually see an m or a b in an equation, okay? So, if I put it in slope-intercept form, I can figure out what type of lines they will be. First of all, once I put it in slope-intercept form, if they have the same slope, what letter in y equals mx plus b is the slope? M. So if I have an equation that looks like this, y equals 2x plus 5 and y equals 2x plus 6, okay, I will know automatically, without graphing, these are going to be what type of lines? Oh, I look and see what they have the same. They have the same M. So I know that these will be parallel lines. All right? Then I'm going to ask you, okay, how many solutions will they have? Well, If I find a solution by where the lines cross, how many solutions will parallel lines have? None, because they'll never cross. So I can write none. So on your homework and on this section, the answers I'm looking for is what type of line is it and how many solutions will it have. So I just said it's going to be parallel lines and it will have no solutions or none. Okay? I can figure what type of line it is by figuring out, do they have the same slope? It's parallel. Now, the next type of line that we have is the same line. So if I were to have equations, okay, that were y equals 2x plus 5 and y equals 2x plus 5, these are the exact same equation. So guess what kind of lines they're going to be? Same lines. If they're the same equation, they're going to have the same lines. How many solutions do same lines have? Infinite. If you want to, you can draw an infinity sign or you can write out the word infinite. Doesn't matter. Okay? And then the last type of line, intersecting lines. These are the ones you've already been doing. Okay? We know that if my equation says y equals 2x plus 6 and y equals 3x plus 5, do they have anything the same? No, I know they're just going to be two regular lines. They're going to intersect at one point, okay? So that means they will have one solution. So they're intersecting lines with one solution. Now, this is what I don't want you to do. This is where people mess up. They go, oh, they have nothing the same, so they're intersecting lines with no solution. No, intersecting lines always have one solution. Remember, parallel lines have no solutions, okay? So the first step you're going to do, put it in y equals mx plus b. If they have the same slope, they're parallel with no solution. If they have everything the same, they're the same lines with an infinite solution. And if they have nothing the same, they're intersecting with one solution. Now, I did put a little asterisk by this, and I said the y-intercepts can actually be the same, and they're still intersecting lines. So, like if my equation said y equals 2x plus 5, and the bottom equation is y equals 3x plus 5, if they have the same b's, that's fine. They're still intersecting. That actually tells me exactly where they're going to intersect. They're both going to cross each other at the y-intercept of 5. Okay? All right, so this is what the questions are going to look like on your homework or test or quiz. I'm going to ask you, what kind of lines are they and how many solutions will they have? What is the first thing you have to do? Y equals mx plus b form. Is this set of equations in y equals mx plus b form? No. So I need to do that. Everybody should know how to do that. You should have learned how to do that back in chapter 6 when we graphed lines. Okay? What am I going to do first, Samantha? Very good. Subtract 2x on both sides. I get y is equal to negative 2x plus 5. Dean, what am I going to do to the next equation?
Subtract 2x from both sides.
Very good. Subtract 2x from both sides. And I get y is equal to negative 2x plus 1. Now let's evaluate. Look at my equation. What do they have the same? The m, or the slope. So what kind of lines are they? Parallel. And how many solutions will parallel lines have? None. So that's my answer. Okay? Seth, what would I do to my next equations first? Okay, slope-intercept form, and how would I do that? Very good. Add 2x to both sides, and I get y is equal to 2x plus 3. Hunter, what am I going to do to the bottom equation?
Add 4x on both sides.
Yep. And I get 2y is equal to 4x plus 6. Now, remember, when you're writing in slope-intercept form, never write 6 plus 4x. You always want to write the x first. Okay? What am I going to do now, Autumn? Exactly. Divide by 2 everywhere. And I get y is equal to 2x plus 3. All right, so let's look at these equations. What do they have the same? Everything. So what type of lines are they? Same lines with how many solutions? Infinite. All right. Now let's do the next one. Elizabeth, what would I need to do first in this next set of equations?
You subtract 2x.
Very good. Subtract 2x first, which cancels out. And I get y is equal to negative 2x plus 4. Jason, what would I do to this next equation?
Subtract 4x plus.
Subtract 4x. Now you say, wait a second, it has a 0 over there. That's okay. We can write negative 2y equals negative 4x plus 0. All right, what would I do now, Hannah? Very good. Divide by negative 2 everywhere. And I get y is equal to 2x plus 0. What do these lines have the same? Nothing. You say, but wait a second. Aren't their slopes the same? Is negative 2 and positive 2 the same thing? No. So, if they have nothing the same, what type of lines are they? Intersecting. And how many solutions do intersecting lines have? 1. All right. Anybody have any questions over this? So remember, there's 3 types of lines. Parallel, same, and intersecting. They have no solutions, infinite solutions, and 1 solution. All right. Go ahead and do these on your own.